Hi everyone! We're really excited to introduce to you an important new update for Griddler 2.5 Pro. Namely, as the subtitle now suggests, it is now for industry solar cells and 2J 2-junction tandem solar cells. And today we're going to talk about this new feature for Griddler to quickly define and simulate tandem solar cells. So let's get to it. Conceptually, a tandem solar cell consists of a top cell and a bottom cell, and they're stacked one on top of the other. This is really as simple as we've built it out in Griddler to make it really easy for a user to go from beginning to end of defining both cells in great detail and then defining the tandem solar cell. So let's go ahead and load the top cell, which has already been previously defined inside Griddler. So as you can see, it's a 2x2 centimeter cell defined in Griddler with a front metallization pattern like this and recombination parameters that are consistent with the voltages you would expect from a perovskite solar cell. So this is our representation of a perovskite top cell. Now let's go ahead and load that bottom cell. So in this example here, our bottom cell is a 4-inch round silicon wafer with typical recombination parameters of silicon solar cell. And it's got a front grid that looks like this and a rear full area metallization pattern that looks like this. Here on the left side, you'll see the overlay of these two cells. So the top view is this top cell laid on top of the 4-inch wafer. And the bottom view, you can see the rear metallization of the bottom cell and the contour of the top cell. So the way that Griddler pieced these two cells together, it actually crops out the top cell part, ignoring the rear metallization pattern. And it crops out the bottom cell part, ignoring the front side metallization pattern. And then it sticks them together, and then it adds these interlayers that connects them together. And we'll get to that in a bit. To start off, let's take a look at these two individual cells' characteristics. We can disable tandem, in which case now we're simply looking at each cell on their own. As usual, we can find the IV curve. So our bottom cell is a 23.75% efficient solar cell under one sun. We can switch over to the top cell and trace its IV curve. So our top cell is a 17.85% solar cell. We now enable tandem, and before we can do the simulation, we need to do some adjustments. So let's go back to the bottom cell. We have to keep in mind that the bottom cell is shaded underneath the top cell, which is responsible for collecting part of the sun spectrum. So that leaves less of the spectrum available for the bottom cell, and we'll adjust its one sun light-induced current density to 21 milliamps per centimeter square. We also have the opportunity to define a different light-induced current density in the area which is not shaded by the top cell. So we're going to leave that as 41.8 milliamps per centimeter square. And now let's go back to the tandem settings. So recall that in stacking the top cell onto the bottom cell, Griddler has created these extra layers that are interlayers. So I will set the upper interlayer shear resistance to a very high value. Lower interlayer shear resistance also to a very high value. And I'll leave the interface contact resistance as is, 1 milliohms centimeter square. And these are typical values because in designing tandem solar cell, we don't necessarily need these interlayers to laterally conduct currents. We can make use of the top cell emitter and the bottom cell backsurface field to do that. We can also define the top cell position relative to the bottom cell. So just to make it interesting, I'm going to shift it to 4 and 1 centimeter, so that is near the edge of the bottom cell. Finally, we can define the front side illumination so that it's not uniform as it is right now. We can actually uncheck this to separately define the illumination that's over the top cell and as well as over the area that's outside of the top cell. So we're going to define for area outside of the top cell to have no illumination. So this simulates the case where for testing purposes, we might have created a top cell that's small on top of a larger substrate, which is the bottom cell. And during tests, we would like to crop the light using an aperture so that it's only over the area of the top cell. And before we start, let's save this bottom cell change that we made. And also let's save this entire session as a zip file so that we can retrieve it later. So this saves both the top and bottom cell files into a zip file, as well as the settings that we have done here that defines the tandem solar cell. Okay, so we're ready to go. So let's take a look at this IV curve. Okay, so the simulation did take 5 minutes, so I have cut straight to the conclusion. So we see that by stacking the top cell on top of the bottom cell to create this tandem, we've created a 28.62% solar cell, which is pretty good. There's of course still a lot of room to go, as the theoretical limit of perovskite on silicon tandems should approach 40%. And hopefully, Griddler with the tandem solar cell feature will help researchers as they go through this design, test, and improvement cycle to make their tandem cells better and better. We can also map the voltages, let's say near MPP. So this is the top cell diode voltage. This would be the top cell front plane voltage. This is the top cell rear plane voltage. This is the bottom cell diode voltage. As you can see, it is over a larger substrate area. And there is considerable spread of this voltage into the dark regions due to diffusive carrier transport. So Griddler automatically takes care of these additional recombination currents that occurs outside the periphery of the top cell when the bottom cell is larger than it. This is the bottom cell front voltage, and finally here's the bottom cell rear plane voltage. Of course, with Griddler, we can simulate a huge variety of scenarios, including the cases, let's say, where the light is uniform and is one sun outside of the top cell area, or if the top and bottom cells have equal size, or even if any of the parameters are non-uniform. For instance, if the interface contact resistance were very high in certain areas, which might reflect a fabrication problem. All these scenarios can be very quickly defined in a matter of seconds and simulated. So that really minimizes the learning curve and allows the researchers to do what he or she does best, which is to design and make solar cells. So I hope this quick intro gives you a good impression of the new tandem feature of Griddler. If there's any questions, feel free to write me, and we look forward to working more with the tandem solar cell community.